I'm going to go ahead and get started. If you're just now joining us, you should have your measurements, lecture slides. Make sure you throw your video on for us. And please make use of the chat as we go. That's one way. I'm constantly trying to look at that. If like something gets disconnected or freezes or glitches on my screen and y'all can't see what I'm writing, please let me know. You can unmute yourself or say something in the chat. If you have a question about something we're going over, go ahead and just ask it or type it in the chat. But that's there for you guys. So I'll try to be checking that as well. If you type a question and I'm like, got my head down, I don't see it, just unmute yourself and you can ask me out loud. Don't be embarrassed to ask, because if you have the question, probably a lot of other people do as well. What else? A couple of reminders too. I'll show you a slide I have for a second that you can take a screenshot of. But we have labs next week, assuming that we don't all get mandated to do instruction completely remote next week. So I know this first week, it was mandated that we have to do it all remote. We didn't have labs scheduled anyway, so that's nice. But next week, make sure you know what lab group you're in. Check the lab PDF on Blackboard. You should either be in group A or group B, depending on, I just did it alphabetical, so on where your last name falls. If you're in group A, my group A people, you will show up to campus next week for your lab. So make sure you know when your lab time is. You're gonna show up. I'm gonna give you, please wear your face covering of choice, but I'm gonna give you, the university will supply you with KN95 masks. And so you can wear that during the lab. We got plexiglass everywhere. You'll have your own individual station. You will complete your lab, and then that's it. You'll go home and you can answer all the questions, the post-lab questions and everything on your own time on the online Blackboard assignment. Okay, you're just coming in to get your data. So please read over the detecting signs of a chemical change, that procedure. It's on Blackboard, and kind of have an idea of what lab's going to look like when you come in. You'll get your data and you'll head out. My group B people next week, you will download the dry lab conversions and density. You'll start working on that on your own time. And then the following week, so the week after next, my group B people will come into lab. Group A people, you'll be doing the dry lab on your own. And then everything is due. Nothing's due next week lab-wise. No labs are due next week, but the following week. And this is all on the syllabus schedule, okay? Have any questions? So I'm going to go ahead and share my screen. I just wanted to make note of that. Also, make sure you sign the safety agreement and the mask agreement forms. I sent the links for those in my email earlier this week. Most everybody, a lot of people sign those, but I still think we're missing a few. Also, make sure you're muted right now. If you're not, I'm getting some kind of background noise, and I'm not sure who it's from. All right. I'm going to share my screen. Oh, question? Yes?
I'm not on any of the lab, like for the A and B, I'm not on there at all.
Okay, if you were recently enrolled, sometimes this happens, like students get put in like the week that classes started. And if that happens, you weren't on my initial roster. So send me an email if you don't see your name on the lab PDF, and I'll get you added, okay?
Mm-hmm.
All right. Share screen. Okay, hopefully you guys can see my screen. And what we're gonna do is, you can take a screenshot of this if you want. Here's just some announcements that I had. Remember, since we are starting labs next week, you need goggles. So if you already have a pair from a previous chemistry or some sort of science lab, great. If you don't, our department, the chemistry department, sells goggles for $10. They sell them on campus. They are the kind, if you wear glasses, they will fit over your glasses. So that's nice. They're $10, and they sell them at the annex. So if you don't know where the lady, or it's Mannion Hall now, but if you don't know where the Mannion Hall annex is, there's a little map right here. Okay. Here is the Prince Center. And then here is Mannion Hall. And the annex is right there. There's a little sidewalk that juts in. If you're walking behind Torsen Library and you just walk right across the road, you'll bump right into the annex if you just keep walking, okay? So you can buy goggles there for $10. They only take Cash App though, okay? So you need to download that if you want to purchase them there. If you don't want to If you don't want to purchase goggles there, you can buy them at Lowe's. I had a student say they got some at Lowe's. Okay, Lowe's, and they were like $10 as well. So you can buy them there if you haven't purchased them. Sometimes online, like Amazon, things get backed up, so it may not arrive on time. Hold on just a second, I'm responding to chat. Also know if you ever need to message me privately in the chat, you can. Oh, someone said $4 at Home Depot. Okay, you guys are bargain shoppers. That's my kind of people. Okay, but this is the times when they're selling them. So anyways, just make sure you show up to lab with those. Don't show up without them. Other important announcements. I'm gonna post a discussion board question to Blackboard. So after our first lecture video, I had a student email me with a really great question regarding precipitations. And some of you may have a question like this too. They said, how do I know if a precipitation, like explain more about what a formation of a precipitation, and how do we know when that's a chemical change? How do we know when changes, states of matter are just physical changes? So I'm actually going to post this question to the discussion board on Blackboard, okay? And if you get on there and respond, I will give you 3 bonus points on your first exam, okay? On exam, just for responding to the question. All right, so this is going to help create dialogue between students, help you guys, and that'll be 3 bonus points towards your first exam. And then also, I added 2 announcements to Blackboard. The first announcement has all the lecture and the lab Zoom links and the passcode. So if you're ever scrambling, like can't find where the Zoom links are, know that they're always going to be posted right there as an announcement on Blackboard, okay, for easy access. And then lastly, I made a tutoring announcement. So our department let us know some details about tutoring. We don't have any department specific tutoring, but I made an announcement about how you can find help tutoring via campus. Also, if you want a private tutor, look at that announcement or email me. I have recommendations for those as well. They're just private tutors and they're not going to be free. But if you're willing to pay for that and want that, then we can certainly supply that as well. I'm also available. I just finished a office hour. Okay, remember every Tuesday, Thursday from 9:30 to 10:30, I'm on an office hour. You can jump on that Zoom link. It's on the syllabus. You can hop on and ask me any questions. We can work problems together. Or if those times don't fit your schedule, you can always email me and we'll set up an individual Zoom, and I'm happy to review any content, material, questions, concerns that way as well. And then due next week, you have some assignments already due. And I noticed we've got like 100 and something students enrolled in our Mastering Chemistry course, which is great, but that's not everybody. So if you've not gotten enrolled in our Mastering Chemistry yet, make sure you do that. The instructions for how to do that are posted on Blackboard as well, step by step. If you have enrolled with temporary access, just make sure you get on and make the payment within the next 14 days so that you don't get shut out from the course. Notice I put in parentheses right here for that chemistry primer. Both of these assignments, the mastering, intro to mastering, and the chem primer are 5 points, but the chem primer is just participation points. So if you just get on and do it, you're going to get your participation points. And I will go into Blackboard and manually update those grades by the end of next week, okay? So don't worry necessarily, people freak out because sometimes those questions can be hard because it's just kind of priming you to remind you some things you may have seen with chemistry before. But don't freak out about getting all those right and wrong. Just get on and give it your best shot, okay? Those are participation points. And then your chapter 1 homework is due next Wednesday evening at midnight, all right? All this is, again, on the lecture syllabus. I just want to remind you this. And I'm going to send an email. That's supposed to be a star. Next week, or by the end of this week, actually, we're going to set up group meets for the courses. Did anybody have those in the fall, group meets for like any classes that you were in? We set up one for the chemistry class, or my chemistry class last fall, and students found this to be helpful. So if you would be willing to start a chemistry group me using the group me app, you can respond to the email that I'm going to send and let me know. And then I will share the joining information with the rest of the class. And that can be used for reminding each other of assignments, for setting up your own individual Zooms and working on things outside of class time together. There's all sorts of ways that group me information was helpful. So I'm going to make a note about that. I'll send an email. And again, if you want to volunteer to set that up, you can just respond to the email. Okay, that's all the announcements that I have. We're going to jump into measurements. And I mentioned this on the video if you watched it, but I like to start off with a hike that I have done. And this one is maybe one of the most memorable hikes I ever got to go on. So I lived, anybody been to Africa before? Anybody traveled internationally? This was a while back, so several years ago, but I got to go live in Kenya for a summer, and one of the most memorable summers of my life. Me and my husband actually met in Kenya. We're both from Arkansas, met in Kenya. But I got to hike this right here. It's a volcano. You can probably see that. It's an active volcano. It's called Mount Longnut. And you can actually hike the rim of this, okay? So we literally hiked this rim in a day, a big circle, and then back down the volcano. It was really impressive. So sadly, this may not be a hike you can go set out to do this semester, but if you ever do travel internationally or find yourself in Kenya, I recommend it. But I will be showing you several hikes around Arkansas later on that you can go do, maybe on some breaks or if you need some time outside. Okay, let's get into the content for today. So we are going to talk about making measurements and how to write out measurements with proper units, how to convert between units. You will need your calculator. So we're going to do some math today. So if you need to grab your calculator, make sure it's one that you can put in like exponents easily. Sometimes it's hard to do that with your cell phone. So if you have another one, I just recommend grab that real quick and have it handy for a little while. All right, let me scroll back up right here. So measurements, what we are doing, if you remember from Tuesday, we talked about chemistry is the study of matter. And one of the ways we study matter is we observe different properties of the matter. And some of the properties we listed out that we could observe were things like mass or temperature, density. But what we're doing is we're looking at a physical quantity, and that's our first blank, that the matter has. And this is just a property that can be measured, okay? And some examples, I'll list some here. We've got mass, length, volume, okay? These are all ways we can examine some kind of matter. We can measure temperature as well. And when we are measuring that, when we're making some sort of measure on these properties, we are looking at a physical characteristic of that matter, okay? That probably makes sense. But what this does is measurements, we also looked at not just studying properties, but how properties change, okay? And that's when we got into deciphering between physical and chemical changes because things change. So if we have some kind of matter and it's gonna undergo a reaction or it's gonna change somehow, we can learn the most about it if we measure it before that change and after that change. Okay, so measurements tell us a starting point and an ending point, but this blank right here is just starting point, okay, for a property. But if we make a measurement afterwards, we also have an ending point, okay? So starting point and ending point for a property. Now, when we make a measurement of a physical quantity, the full way to measure it is with both a number and a unit, okay? A number and a unit. And here's what's gonna happen. This is the most important point on this slide, okay? Making sure you include the unit, because here's what's gonna happen. You're gonna go through different labs next week. People are gonna do it. They've always done it. And people are gonna write down how to solve a problem, show all their work, and they're not gonna include a single unit, okay? And that's going to be a problem for me. It's going to be a problem because you're going to lose points if you do that. But it makes it very hard for me to follow your work. And here's why. Because units, numbers, they don't mean anything if you don't have units. For example, if I just tell you this phrase right here, I'm 66. You have no idea what I mean. 66 what? Okay, I could mean many different things. I could mean that I'm 66 years old. Is that what I mean? Do I mean that I'm 66 feet tall? Yeah, right, you know. Do I mean that I'm 66 pounds? Definitely not. But I'm just trying to illustrate the point. There could be so many different meanings unless I give you more information. And so just remember that when you're trying to tell me how to work a problem or show me that you know how to work a problem, I don't know what you mean if you just write down a bunch of numbers, okay? But if you give me the units, then I can follow your work clearly. So numbers are meaningless without units. To get full credit on work that you show me in this class, you have to put units on all numbers, okay? So a little bit more about units. They tell us what we're measuring, obviously. So if I have units of, if I have that unit, what am I measuring? If you see that unit on a number. You can type it in the chat or say it.
Degrees Fahrenheit.
Yeah, I'm measuring temperature of something, okay? That is the unit for degree Fahrenheit. If you see the unit of grams, okay, or pounds, DS, and you know we abbreviate pounds, LBS, you know that I'm measuring the weight or the mass of something, okay? So they tell us what we're measuring. They also give a reference point. I always use this illustration when I was in graduate school. I had tons of friends from different countries. And my best friend was from Iran, okay? She lives up in DC now, and we still talk. And in Iran, they measure temperature in degrees Celsius on the Celsius scale, okay? Now, we measure temperature in Fahrenheit. So you probably understand if I tell you I keep my house on about 70 degrees Fahrenheit, all right? You understand what that would feel like. But she would tell me, well, I keep my house around, does anybody know what room temperature is on the Celsius scale? If you do, you can type it in the chat. Okay, someone said 37, that's body temperature. Body temperature is around 37 degrees Celsius, but room temperature would be around 20 degrees Celsius, okay? So if I know the room temperature is 20 degrees Celsius and she tells me in Iran today, it's 54 degrees Celsius, because I have a reference point, I know, oh, that's really, really hot. So they give us a reference point. Now in the sciences, we use metric and we use SI units, okay? In this course, we're mostly gonna focus on metric units, but I want you to understand there's something called SI units. What this stands for is a system of international units. Can anybody think of why that would be important to have a system of international units?
So that everybody can use them.
Because easier communication between languages, yes, right? The United States is not the only place we do research. It's not the only places we have medical or breakthroughs or any kind of research like that. We have to be able to communicate internationally, okay? Space stations, all kinds of stuff. So anytime a research article is published, a lot of times, very commonly, they'll use SI units. And that way, research and things, medicine can be repeated, in any country across the globe. Here's a table just to show you the units for the SI system, and sometimes they're different from the metric system, depending on what you're talking about. So here's the quantity that we're talking about. So for mass, the SI unit is the kilogram, but for us, the metric unit is just the gram. So what is the difference between a kilogram and a gram, you may wonder? Well, that's where this last column over here comes in. This actually will tell you the relationship between those units if they're different, okay? So 1 kg, 1 kilogram is 1,000 grams, all right? And we're gonna get to prefixes. Kilo is actually a prefix that we put before a word to change the size of it, and we'll get to prefixes at the end of today. But there it is right there already. Sometimes they're the same. We have meter for the length on both systems, both seconds, okay? Anyways, I just wanted to introduce this to you, but we're mostly gonna use the metric system, okay, in this class. All right, so that's a little bit on units. Now we're gonna get into scientific notation, so grab your calculator. We're gonna explain scientific notation. This will probably be a review for a lot of you. You already heard of this or use this or know how to do it. But this will be a good review because there's gonna be a lot of times you calculate an answer that's either really, really big or really, really small, and it'll help me and it'll help you to write it in scientific notation so that the numbers are more manageable, okay? That's the purpose of them, to make very small or very large numbers just easier to look at and to read. So what is scientific notation? Well, there's a format, it's just a format for writing numbers, okay? And here's the format. A times 10 to the power of B. B is your exponent. A times 10 to the power of B. So what does this mean, A and B? A is a number between 1 and 10. Okay, we're going to call this, I think the wording on the slides later is the digit. the digits. Okay, I might call it the base number or the digits. That's A, and that has to be a number between 1 and 10. So if you calculate something and you end up with 0.5 times 10 to the power of 2, is that correctly written in scientific notation? No, it's not, because this is not a number between 1 and 10, right? You would want to move the decimal one more time and fix your exponent. So make sure your digit or your base number is between 1 and 10, and then B, the exponent, this is going to be the number of places that the decimal moved, and you'll see what I mean by that in just a second, because we're actually going to put this into practice now. We have two numbers here at the bottom of the slide, and these are written in what I call standard notation, okay? Standard notation. We're going to convert these to scientific notation. So looking at this first number right here, this number is 83,910. But we only know that because we understand currently that there is an invisible decimal in this number, okay? Currently, don't put it in scientific notation yet, but just as standardly written, where is the decimal in this number? After the what? After the 0, yes, okay, it's right here. So if I'm gonna convert this to scientific notation, I have to make it a number between 1 and 10. So I have to move the decimal. So go ahead and do that. Where would we move the decimal to?
Behind the 8?
Yes, behind the 8. So I'm gonna move it 1, 2, 3, 4 places to the left. Now I have a number, 8.391 times, we gotta finish out writing the format, times 10, and B is the number of the places that the decimal moved, and it moved 4 places to the left. So I'm gonna write a positive 4 as my exponent. Now, there's a rule, it was implied, but I'm gonna write it out, that we just learned, okay? If the decimal moves left, the exponent increases, okay? We have a positive 4 here. Notice that I didn't write the exponent's always positive. There will be times where you're totally still working with negative exponents, even though you move the decimal left. But it will increase towards the positive direction if you move the decimal left. All right, now let's do the second number right here, 0.000596. We want to make this into scientific notation. So make it a number between 1 and 10. To do that, you're going to put the decimal behind the I'm looking at the chat. Yes, behind the 5. So it'd be 5.96 times 10. And we're going to this time move the decimals right here. We're going to move it 1, 2, 3, 4 places, but it moved to the right. So this is going to be a negative 4. Okay. And the rule that we just learned from this is that if the decimal moves right, the exponent decreases. Okay, so remember these two rules in the coming slides. We're going to need that. We need to come back to those rules. Questions so far? Okay, let's keep going. So we got a practice slide. For time's sake, we're not going to do every single one of these. But I want you to do, we're going to do, let's just do the first 3. We'll do the first 3. Okay. So take these top two numbers are written in standard notation, write them in scientific. And then number 3 is already written in scientific notation. I want you to reverse it and write it in standard notation. So go ahead and start that, attempt that on your own. Okay, for the first one you may have done, the decimal should be here. I'm going to go ahead and write this out. What did you guys get for the second one? Anybody have the second one done? You can type your answer in the chat. So I got 6.5932 times 10 to the power 4. Okay, in the chat, I'm seeing we got 8.37 times 10 to the negative 7. Make sure your exponent's negative there because we're moving the decimal to the right 7 places. Okay, good. And then lastly, for these, this is a scientific notation number, number 3. You could put this in your calculator and see what it gives you. Or you can understand, I'm going to multiply 7.41 times 10 to the power of 8. Okay, that's like 100 million, right? So we're going to move the decimal 8 places to the right to undo this number. Yeah, so you should have 741. I think that's right. I'm too lazy to count zeros. 1, 2, 3, 4. I think you should have 6 zeros to move it 8 places total. Okay. All right. Any questions with how to convert back and forth between standard and scientifically written numbers?
On number 3, wouldn't you move left if it's a positive?
Well, when you're undoing scientific notation, this is like multiplying 7.41 times 100 million.
Okay. So
you should get 74100 million. Okay.
Okay.
So it's a really, really big number, right? And always double check yourself on your calculator if you ever have questions about that.
Thank you.
That's when you're the rules kind of reverse when you're converting back from scientific to standard notation. Okay. All right, great question though. Okay, now we're going to look at addition and subtraction, multiplication and division, and that'll be it for scientific notation. Then we're going to move on to something else. So when you're trying to add or subtract numbers written in scientific notation, there's a rule, and the rule is that the exponents must be the same, okay? So we have 2 numbers here, 7.41 times 10 to the power of 8. That's actually the number we just wrote. And we have 4.32 times 10 to the power of 10. And you'll notice our exponents don't match, okay? We have 10 to the power of 8, 10 to the power of 10. So we need to pick one of these numbers, convert it so that the exponent matches, and then we can add the numbers. So in the next line down, it's already been done for you. They took the first number. We want the exponent to increase from 8 to 10. So we're going to move the decimal 2 places to the left on this number. They took it, it was right here, and they moved it 1, 2 places to the left, and that increased the exponent from an 8 to a 10. Okay, now the exponent here matches the exponent over here. So you literally just put the numbers in your calculator, 0.0741. I would put these in parentheses, by the way, if you're doing it in your calculator. And you'll add those, and you will get this answer. And you have to make sure, again, that it's a number between 1 and 10. 4.39 is. So you're done. You have your final answer, okay? All right, this next problem, we have 2 different numbers. Again, our exponents don't match. We have a -5 and we have a -8. So we're trying to subtract these. So we need to pick one or the other, convert it so that the exponents match, and then we can subtract the numbers with their matching exponents. You need to think about that. You can do it either way. Just make sure when you get your final answer that your base digits are a number between 1 and 10. So I want you to go ahead and attempt this on your own. I'm going to launch a poll question on Zoom, and I want you to put in your final answer or select your final answer. You'll have 4, it's like a multiple choice question when you're done, okay? And then we'll see kind of what everybody picked. So go ahead and start it. I'm going to launch the poll. It's not really timed. I'll give you a couple minutes. you're not sure where to start, what I would like to do is I'm going to take this second number and I'm going to convert that exponent to a -5. So we have currently a -8 and we want it to, is it going to increase or decrease if we make it a -5? And the negative scale, remember the larger numbers are lower down the scale. So if you take the exponent -8 and you convert it to -5, we are wanting it to increase. And remember the rule, if we want our exponent to increase, we're going to move the decimal to the left. How many places? Should be 3 places. So 1, 2, 3. So what you should end up with is 0.00286. Now we have times 10 to the -5. Okay, you should get an answer that matches one of the 4 on the question. So if you get something else, double check. You should not get when you do the complete total problem, you should not get a negative number. So that's just converting it. Now we're going to take this first number and do the subtraction problem. And again, I like to put, we're actually subtracting this number down here. I'm going to give you about 20 more seconds. If you don't get your answer in, it's okay. We're only about 50% there so far. All right, I'm going to go ahead and call the poll. Just go ahead and guess. If you need to just choose one, just go ahead. I'm going to end it so we can look at it and kind of move on. Can you show how you were if you convert the other side? Yes, I can. I'm going to end the poll real quick. Let me show the results. Okay, share results. So the most popular answer that was chosen was number 2. 3.0181 times 10 to the -5. And this is the correct answer, okay? So that's what you should have gotten. If you chose nobody chose the first answer. If you did, that's wrong because it's not a number between 1 and 10, right? If you chose the third answer, which was the next most popular answer chosen, then instead of subtracting the numbers, you added them, okay? And that's why you chose the third one. And then if you chose the last answer, you subtracted correctly, but you just chose the wrong exponent. Remember, we changed our exponent to be -5s, not -8s, okay? So if I were to pick the first number and convert it, because you can do that if you want to. I'm going to erase for a second. If you were to take this number, we want to take the exponent of -5 and we want to make it -8. So we're trying to decrease our exponent, which means we move our decimal 3 places to the right. Okay, so literally we're going to go 1, 2, 3. So now our math problem becomes 3021 times 10 to the -8. And we're going to subtract off 2.86 times 10 to the -8. The problem here is now I have a number of 3021. And when I do this subtraction, my base digit number is not a number between 1 and 10, okay? That's why I thought it was easier to take this number and do it that way, okay? I hope that answers your question, Alan. All right, I'm gonna stop sharing and we are gonna move on to the next thing. Any other questions on addition and subtraction? All right, let's look at multiplication. Here's the rule. You're going to multiply your base digits and you're going to add the exponents. I think this is simpler because there's none of that manipulation stuff with moving decimals. So we have the same two numbers as previous on the previous slide, but this time we're gonna multiply, okay? So you're literally gonna do 7.41 times 4.32. What do you get? And then we're gonna look at our exponents. We have 8 and 10. So for the exponent part, so we'll write our base number here, but it'll be times 10, 8 plus 10 is 18. So times 10 to the power of 18. Yeah, that's a huge, huge number. Anybody do that multiplication yet? Haley said she got 32.0112. Thank you, Haley. 32.0. What's my issue though? Not a number between 1 and 10. 32 is greater than 10. Thank you, Bianca. So we need to manipulate this. What do we need to do to it to get it in proper scientific notation? We're going to take this decimal and move it one place to the left. And remember, when the decimal moves to the left, the exponent increases. So this actually should be 3.2. And you can round. You're gonna learn. I'll just tell you now. I am not a Nazi when it comes to sig figs. If you can give me 1 or 2 sig figs or decimal places, I should say, that's great. All right. So if you were to tell me this answer was 3.20, that I'm fine with that. Okay. You don't have to give me 8 decimal places, but try to be as accurate as you can where possible. But I'm not gonna count off if you don't have the perfect number of sig figs every time. Mastering chemistry on your homeworks will probably have you do more sig figs than I'll have you do, but that's just the way the software is set up. I wish I could change some of those features. I just can't. But in course on quizzes and exams and things, don't worry yourself. Is she gonna count me off if I don't have the right number of sig figs? I'm not. Oh, not 18. Sorry, this should change now. It should be times 10 to the, it went up 1, so 10 to the 19. Okay. Any other questions on that? You would do the same problem here on the second number. Go ahead and do that. 3.021 times 2.86. And then whatever that number is, it would be times 10 to the power of, our exponents here are -5 and -8. And what we're doing, we're adding the exponents. So you do -5 and then plus, I like to put it in parentheses, -8. What does that equal? Should be -13. Jonathan and Haley all got 8.64. Thank you. Okay. And this is already a number between 1 and 10, so we have nothing else to do here. We're done. All right, so that's multiplication. I know I'm kind of moving through this, so if you have any questions, slow me down. Or the nice thing is this is all recorded, right? So you can go back and rewatch this at any point. All right, lastly, we're going to look at division. The rule, when you divide numbers that are both written in scientific notation, you divide the digits, subtract the exponent. So it's just the opposite of multiplication. So we'll do 7.41 for this first one, divided by 4.32, and you can just put that in your calculator. Whatever that equals, then you do times 10, and we're going to subtract our exponents. We have 8 minus 10. So that should be -2 exponent. And apparently it's 1.71. Okay. All right. I'm going to skip over that last practice problem. You can practice this on your own if you want more practice with that. But for time's sake, we're gonna push on to the next. That's kind of it for scientific notation. So I want you to be able to know how to do these things. For quiz 1, by the way, anybody know when your first quiz is? Well, you technically had a quiz already, right? With that first lecture, but your first graded quiz. It's next Tuesday, okay? So next Tuesday, right around 8 a.m. or so, I'll open the quiz up. It'll be 5 multiple choice questions. You can get on Blackboard and it'll be open all day long. You'll have about 20 minutes to complete the quiz, and it'll be over material from today and from Tuesday's video. Yep, you can use your notes on it. All my quizzes and exams are open note. I just ask that you don't just use the internet, because then I'm not quizzing you, I'm quizzing the internet, and I want to quiz you. So you'll sign an academic integrity form with that. And that's kind of how the quizzes work. If you have any other questions, let me know, but know how to do this kind of stuff for the quiz. Yeah, the quiz yesterday was not for a grade. I got a lot of emails on this. It was for attendance purposes. I wanted to make sure you watched the video. And so putting that little quiz on there, I can see who has and has not done the quiz. Just let me know who was watching the video content and keeping up with the material. Okay, so that was the purpose of the quiz. Okay, the quiz did count towards your knowledge. That's what it counted towards. All right. All other quizzes will be for grade, I promise. Okay, so we're now gonna switch gears. We're gonna go back to some properties that we mentioned earlier. And we're gonna talk about properties of length and mass and volume, okay? So the first one, length, I'm gonna introduce the metric unit for these properties again, and then we're gonna look how to apply prefixes to these units and how to convert between different prefixes. So length, let's talk about length for a second. Length is a measurement, obviously, of distance. All right, and the base unit, what is the metric unit for length? If you go back to that table, it was the meter. All right, now, right here in purple, it says, I want you to have a tangible understanding for what a physical meter is, about how long that is. If anybody watches football, you know in football, they measure off the field in yards. So that's what you see on this picture here is a yard. I think that's a meter stick laid out to show you that 1 meter is roughly the distance of 1 yard, okay? So that's the English comparison, 1 yard, and that gives you a rough feel for how long a meter is, okay? We have other units too, though. The next one I introduced, so the next slide's pretty much the same, except for what if we're talking about a centimeter down here at the bottom. A centimeter is, well, you are familiar with this probably from rulers because they measure in inches and then on the other side centimeters. So 1 centimeter would be about the distance right here. And if you hold kind of your finger up the way this picture shows, it's about the width of like your pinky, all right? So there's that. Unless I always tell people, my husband's grandfather, he owns his own glass business. So his whole life he's carried like these huge windows and like glass paneling and things. So his fingers are insane. He wears a size 15 ring. It's like, we say he has Ninja Turtle hands. But his pinky would not be the size, the width of a centimeter. He doesn't count. So for a normal human hand, about the width of your pinky. Let's scroll down. What about a millimeter? If I say we have a millimeter, or this particle is the size of a millimeter, what do I mean? How big is that, or how small is that? Well, if you continue to look at this picture of the ruler, in between a centimeter, so there's 1 centimeter in red, well, there's 10 different tick marks breaking up the distance of that centimeter, and the distance between 2 of those marks is a millimeter. Okay, so a millimeter is 1/10 of a centimeter, so it's even smaller. So if you see this pencil, about the width of the pencil lead is about a milliliter. Okay, so I just want to give you, these are probably some silly examples. I just want to give you something tangible to think about, so you know ballpark how big these distances and units are. All right, here's a table. This is hopefully going to be very handy for you. This is all in your textbook, but it's just a table that gives you equivalents. They tell you relationships between different units. So if you're trying to convert from meters to milliliter or millimeters, or even down here, it's got some other stuff, miles to kilometers. That's a very helpful one. Yards to meters, or 1 foot to how many meters is in a foot. You can use this table to do different conversion problems that you may run into on the homeworks or on that dry lab that you got to do. All right, that's linked. Let's talk about mass. Mass is another physical quantity we can measure. And the first thing that people very commonly, it's a misconception, is that mass and weight are the same. Mass and weight are not the same. Mass and weight are different. And they're different because your mass does not change no matter where you are, okay? On planet Earth, you have a set mass once you reach your full adulthood, okay? Mass is the amount of matter in an object, but your weight depends on the gravitational pull here on Earth, okay? Because that's where we are. Now, if you were to go to the moon, your weight would be different because the gravitational pull would be different. Anybody know how much you would weigh roughly on the moon? It's roughly about 1/6 of your body weight on the Earth, okay? But the base unit for mass is the gram. So to prove that to you, how much is a gram? How big is a gram? We don't commonly talk about grams often, but if you look at this picture over here, I have this balance and we're actually weighing a dollar bill, and you can see that dollar bill weighs about 1 gram. Okay, so a gram is not, it doesn't weigh a lot. It's very, very light. $1 bill. That's roughly the English comparison. And then what about a kilogram? Okay, kilo is a word. We're going to talk about prefixes in a second. It's a prefix we can put in front of the word gram. And how does it change the quantity? It makes it bigger. A kilogram is a lot bigger than a gram. But roughly how much does a kilogram weigh? It's about the mass of a loaf of bread, okay? Anybody have Dave's Killer Bread before? It's like my favorite bread ever. My daughter would eat a slice of this bread with nothing on it. Honestly, it's really good. Any dietetics people out there? Look at that, 21 whole grains. We got seeds in there. You got omegas. Anytime I can pause and talk about food, I will. Are y'all okay with that? I know it's like almost lunchtime. Okay, here's a table of equivalents for mass as well. So you've got the relationship between kilograms and grams, all kinds of stuff. We'll talk about milli and micros in a little bit. You've got useful stuff for pounds to ounces and things like that. So just make use of that as you need to. And then lastly, we're gonna talk about volume. Okay, so volume is a measurement of the space occupied by an object. Okay, and the base unit there is the liter. And we abbreviate liter with a lowercase l. Lowercase, sometimes you'll see it capitalized if it's with a prefix like milliliter. We measure volume. A lot of times we have our own specialized equipment for measuring volume, like graduated cylinders and volumetric pipettes and syringes, because we're usually measuring something that's a liquid, right? By the way, if we're going to use things like a graduated cylinder to measure a liquid, the volume of it, if you look really close, you'll see that the top of it is curved, right? This is probably a review. You probably know what I'm about to get at. Where do you take the reading? If you're trying to read something that's curved, do you take it over here at the side where it might be higher? Do you take it down here at the dip or the bottom of the curve? And what is that called? Anybody remember? Yeah, the meniscus. Okay, yep, the bottom of the dip. And that is where you would take the reading. So just remember that when you come in the lab. Okay, what is the English comparison to the liter? The English comparison is a quart. So you guys might be familiar if you've ever changed your own oil before, you go buy a quart of oil at the store. My favorite, though, example, I know that a quart is, anybody that cooks, a quart is 2 pints. And my favorite thing to buy in pint size is my favorite ice cream, okay? Which is right here. I just had to show you guys. This is like, Jenny's is a household name in our home. Sadly, you can't find this ice cream at Walmart, okay? You gotta go to one of those bougie stores like Whole Foods which I love. Okay, no knocking on there. I'm just saying it's not the cheapest ice cream. So, but I'm serious. If you get a chance to buy Jenny's, do it. You will thank me. Okay. But that's roughly the English comparison to a liter is a quart, which is 2 pints. So you might be familiar with how big a pint is. So it gives you a rough idea. And then what if we're talking about a milliliter? How much volume does a milliliter occupy? We actually measured out a milliliter of water. It's kind of hard to see, but it's about the volume of your pencil tip or the tip of your pinky, okay? So again, I'm just giving you tangible feels for how big these units are. I think this is important for you to know. One, you can double check yourself sometimes without doing any math. Does my answer even make sense on certain problems if I know how big these units are? Sometimes you can just check yourself with common sense, again, if you have a tangible feel for this stuff. What about, oh, one other thing I wanted to mention on a milliliter. Sometimes we can measure volume, not with graduated cylinders. Sometimes we can measure things in what we call cubic distances, but we can only do that for shapes that are very regular and things we can measure with like a ruler, okay? So for example, we have a cube right here. And this cube has nice straight edges. So we could measure the depth of it and the width of it and the height of it. And if we do that and we found it's a centimeter on each side, we would call this a cubic centimeter, okay? Now the volume of a milliliter, like you saw in that graduated cylinder, is exactly equal to the volume of 1 cubic centimeter. Okay, this is gonna be a very important relationship, especially when we talk about density, because sometimes we measure density of objects with cubic centimeters or cubic distances. Sometimes we measure them with, volumetric units like milliliters, okay? But just know 1 milliliter is equal to 1 cubic centimeter. To give you another visual about how small a cubic centimeter is, if you were to look at this cube right here, this is 1 cubic meter, a cube that measures a meter on each side. And if you were to divide that up into 10 equal cubes along each side and then take one of those, we now have a cubic, what we call a cubic decimeter. This is, if you measured the volume of it, is equal to 1 liter. And if you divide that up to 10 equal cubes on each side and take one of those, that is your cubic centimeter. It's pretty small. And again, that is equal to 1 milliliter. You do not have to memorize all these relationships. I do just want you to know this one, okay? All right. That's it for volume. There's a table of equivalents as well. So you can make use of that as you need to. That's it for the units, okay? We're not done with units though, ever. From this point on, units will always be important. But we are gonna pause and talk about prefixes, okay? All right. Once we talk about prefixes, we're just gonna work problems until we've hit our time for the day. So prefixes, what is a prefix? Well, they're important because in science, we often deal with numbers that are really, really big or really, really small. For example, everybody has been talking about virus particles lately, right? Did you know the size of a virus particle is that many meters? 0.00000. That is what something that small is wrecking our entire globe, right? But that's kind of hard. It makes my head hurt to look at that many zeros. So the reason we're going to use prefixes, you could use scientific notation if you want, that would help. Or you can just throw a prefix on there and write a different number, and you can manage the number that way as well. Another example, it's that many meters to the sun. It's like 150 trillion, I think. That's a really big number. It's hard for us to comprehend that. So if we just use a prefix and change, we can either change the number, right, in scientific notation, or we can change the unit and just write a more manageable number. And that's what I'm going to do here with prefixes. From the English, language, that a prefix is a word we put in front of another word. So if I were to say Mr. Mike, okay, you understand that Mr. provides some information. I know that this is a male, okay? If I were to say Dr. Jones, okay, a prefix denotes added information to the word it comes before. And that's what prefixes are going to do here. So it just makes the numbers more manageable. And it gives us reference. So, for example, instead of saying a virus is this many meters, we could say it's 120 nm. Does anybody know what N stands for? Yes, Bianca says, Keyshawn says nano. Okay, nano is really small. Okay, or we could take the second number, 150 trillion meters, and we can say instead 150,000 capital MM megameters. Or we could say it's 150 million km. You guys probably are familiar with this. Km is kilometers or kilometer to the sun, okay? And these numbers, 120, 150,000, 150 million, these are more manageable, right, than those initial numbers. Okay, so that's an intro to prefixes. I want to give you kind of the full spectrum now for the prefixes I want you to know in this class. By the way, these prefixes can be put in front of any one of these base units. What do I mean by base unit? Well, that's what we just talked about. Liters, meters, and gram. Those are your 3 base units, okay? So we could put these prefixes, kilo, hecto, deca, all these right here, in front of any one of these 3 base units. So when it says base unit over here, know that it could be liter, meter, or gram. So first off, some of these prefixes that we're going to talk about, some of them are larger, like they make the unit larger, and some of them make the unit smaller. So these 3 up here on top, these 3 are larger than the base unit. I'm going to abbreviate. Okay, if you put these prefixes in front of the word liter, meter, gram, now the quantity is larger. And then the ones on the bottom underneath the red line, these are smaller than the base unit. Okay, if you put these prefixes, now you have a quantity that's smaller. So let's fill in these blanks to look at the relationship between the prefix and the base unit. If I have 1 kilo, how many base units? If I have a kilogram or a kilometer, how many of the base unit do I have? Okay, well, I bet you guys already know this. If I tell you that I buy a car for 1K, how much money did I pay for the car? $1,000. Is that a good car or a bad car? You're probably gonna tell me, take that car back. Don't buy that car, okay? 1,000 base units, okay? So a kilo is bigger by 1,000 because it takes 1,000 of our base units to equal 1 kilo. So what about a hecto? We abbreviate that with H, that's 100. What about a deca? How many years are in a decade? 10. Some of these you're more familiar with than you probably realize. Okay, we abbreviate deca, DA. Okay, those are the ones that are bigger than the base unit. What about the ones that are smaller? A deci, abbreviate D. These are smaller, so it takes multiple of them to equal 1 base unit. So there's 10 deciliters in a liter, 10 decimeters in a meter, okay? Centi, 100. There's 100 centimeters in a meter stick. Milli, how many millis are in one? If you have liters, how many milliliters are in a liter? Some of you may be familiar, especially anybody that have a job in a hospital, work in a hospital. Yeah, 1,000. Micro, notice, and by the way, I haven't been pointing out the abbreviations, but centi is a lowercase c, milli, lowercase m. Micro, I want to point out this abbreviation. It's a U, but don't forget the tail on the front here. It has this extended tail. That's important to don't just write U. Okay, a micro, there's a million. So you can either write 10 to the 6th if you want, or you can write a million. So micro is really small. So as we're going down, we're getting smaller and smaller and smaller. What about nano? Anybody know how many nano liters are in a liter or nanograms in a gram? It's a billion. I'm going to write 10 to the power of 9 because I don't want to write all the zeros. But you need to write 9 zeros if you write it out. Okay. Now, here's the deal. If you like scientific notation, the next slide I'm going to show you, you can write it all like this. These are the exact same relationships, just written with scientific notation, okay? This is fine. And different people have learned this different ways. For example, some people may have learned that 10 to the minus 3 kilo is equal to 1 base unit, okay? It's the same information though that we have. There's so many different ways you can write these out. Some people may have learned that 0.001 kilos equals 1 base unit, okay? Oh, I'm running out of room. So whatever way you learned it, if you learned it differently, as long as your relationships are correct, I don't mind you writing them in a way that's comfortable to you, okay? This is just the way I present it in this class. And if all that confuses you, what I just wrote over here, just ignore it and go with what I just showed you. All right, well, with the time we have remaining, we've got a little less than 15 minutes. We're gonna work some problems. One thing I'm gonna mention though, which of these are so common that I'm not gonna give them to you on an exam? Obviously, you're gonna have your notes, so you can go look any of this up, but I encourage you, exam days are already gonna be stressful. There's 4 that I recommend you memorize so that when the time comes, you just know them and it helps you complete your exam in a timely manner. Here's the ones I recommend. Kilo, that one's very common, so memorize the relationship there. Centi, milli, and micro. Okay. Those are the 4 I recommend that you go ahead and memorize. Okay. All right, now we're just gonna work some problems. So grab your calculator and let's talk about what a conversion factor is. So we call these problems simple conversions because we're gonna be converting between different units, all right? You do this already, probably more than you realize. If you go to the store and I tell you I need 24 eggs, you're gonna already convert to your head. You're gonna say, how many dozen eggs do I need to buy? Okay, because the word dozen is a conversion factor, okay? The word dozen, 1 dozen equals 12 items. Okay, this is a relationship. We're gonna use stuff like this all the time. And so you can convert to units of, instead of eggs now, individual eggs, you can now talk in units of dozens, all right? So that's what a conversion is. That's what we're gonna be doing just with grams and nanograms and milliliters and all that fun stuff. So we're gonna use conversion factors to obtain an equivalent quantity just with a different unit, okay? So a conversion factor is simply this. It's a relationship between 2 units. Just like I wrote up here, that's a conversion factor, okay? That's a relationship between 2 units. All right, we'll do most of these problems. We might skip over a few here and there to get to some later ones. I have one more poll question with one that I want to launch before time's up. But let's just start with the first problem. Here's our first question right here. 1.36 kg. I will often abbreviate units, okay? So you need to know the abbreviations. What is kg? That is a kilogram. We want to know how many grams is that, okay? So there's some information we need if we're going to answer that. And it's right here written out for you. Here's the relationship or the conversion factor between these 2 units. Here's unit 1, and we're going to convert to unit 2, which is grams. I know, and we wrote this earlier, you can always slide back up to that previous table, that 1,000 grams is 1 kilogram. All right. I have now also right here, I've written that same information just in a factor type of form with a numerator and a denominator. So which one do we need to pick when we're doing math? Okay, we want to cancel out the first unit and convert to the second unit. So to cancel something out, what do you have to do? You have to have that unit on top and on bottom, okay, to be able to cancel something out. So if I write 1.36 kg and I'm going to multiply it by one of these factors, okay, I don't know which one yet. Which one would let me put, I have kg on top already. I want to write kg on bottom so that it cancels out. So I need to pick the one on the left. Okay, yep, the first one. Thank you, come on. So we're gonna write 1 kg on bottom, 1,000 grams on top, and then I'll show you in black, kilograms cancel out. Now we're gonna do the math. So it's not enough just to show me that the units cancel, although you need to show me that. I want you to now do the math. 1.36, here's my multiplication sign, times 1,000. And then you have this 1 down here. You could divide it by 1, but that's not going to change your value. So you can ignore it if it says divide by 1. But make sure you do 1.36 times 1,000, and you should get 1,360. Sorry, not kilograms. Now we just have units of grams. That's the one that didn't cancel out. So that's the unit that goes on our answer. Okay. All right, again, if the way I'm writing my numbers, if you like to write them differently, people can write them different ways and it's still, you get the same answer, okay? So if you don't like my exact way of going about it, as long as your work makes sense and I can follow your units, that's okay. Do it a way that's more comfortable for you. Let's skip down here and do the third one, right here. 1.23 liters, how many milliliters is this? So I have my relationship between the two units. 1 liter is 1,000 milliliters. And then I have my 2 conversion factors. Write out the number that you're given to start, 1.23 liters. And you're going to multiply it by one of these conversion factors. You want liters to cancel. You want milliliters left over. So you should pick the second conversion factor and write it just as is, 1,000 milliliters on top over 1 liter on bottom, because I already have liters on top when I first started writing my problem. So liters on top, liters on bottom, those cancel. And now you do the math. 1.23 times 1,000 divided by 1. You should get 1,230 milliliters. Okay. Questions on any of that? These are what I call simple conversions because they're a one-step conversion. Okay. All right. We have a couple of minutes left. I would like for everyone to do this problem right here. And then if we have time, we'll do one that I have a poll question for. I want you to try this on your own. 374 UL. What unit is that? We want to know how many milliliters. We want to convert from UL to ML. So you need some information. If you need to go back up to those tables where we wrote out the relationships, you can. But you're probably not going to find a relationship directly between microliters and milliliters. Okay, so here's what I would encourage you to do. I would encourage you to write out how many microliters is in 1 liter. You do have information for that. And how many milliliters is in 1 liter? We do have information for that. So how many microliters is in a liter? Anybody help me out with that?
A million, right?
Yes, 1 million. So you can write out 1 million. I'm just going to write 10 to the power of 6. How many milliliters is in a liter?
1,000.
Yep. You can write 1,000 or 10 to the power of 3. Now, I want a relationship directly between microliters and milliliters. So hang with me. If both of these equal 1 liter, then are you okay if I say 10 to the 6 microliter equals 10 to the 3 milliliters? If they both equal 1 liter, don't they both equal each other? Okay. This right here is what's going to be most beneficial for this problem, because now you can just do it in one step. You want a direct relationship. And if you can relate 2 units to the same thing, then they equal each other. I hope that makes sense. So to start the problem, 374 microliters. Now I'm going to write this as a conversion factor. One on top, one on bottom. I want microliters to cancel. So 10 to the power of 6 microliters on bottom, 10 to the power of 3 milliliters on top. Now I have microliters on top right here. I have it on bottom, so it cancels. Now when you go to put this in your calculator to do the math, you do 374 times 10 to the power of 3, and then you divide it by 10 to the power of 6. I like to put some of this in parentheses to help me out. Anything that's on bottom down here, you're going to divide by that. So what'd y'all get? Claire said she got 100. Okay, everybody got 0.374, and the unit is milliliters. Good. Okay, we have 4 minutes left. So I have a poll question on this one. Nanograms and micrograms, we're gonna do that, and then that's it, we're done. Beyond in the chat, the L in liters is capital because the milli. Does that apply to all or most prefixes? Yes, when I write nanoliters, I always capitalize the L. Microliters, I usually capitalize the L for liters. Bianca, I hope that answers your question. Okay, let me pull up my poll question. So I want to know how many micrograms is this? You start working it. I'm going to start working it. Let's see where we land. We need a relationship between nanograms and micrograms. I know how to relate both of these to the gram. So if you can write those, remember, because they both equal a gram, we can say those are equal to each other. Can y'all hear my son right now? He's losing his mind in the other bedroom. So once you have your relationship right here, start with the number given, 578.965 nanograms. You're going to multiply, you're going to write this information as a conversion factor. You want nanograms to cancel. So if you write it like this, nanograms cancel out. Okay, go ahead and do your math and put your answer in. We're really almost at time for class, so once we finish this, we'll be done. I just want to show the poll results. And if anybody has questions, I'll stick around and answer questions for a couple minutes. So we do 578.965 times a million divided by a billion. Okay, we're halfway there. I'll give you about 15 more seconds. I know it's rushed. If you don't get your answer in, it's okay. All right, I'm gonna end the poll since we're at time. I'm gonna share the results. So you should have gotten, the most common answer was 578.965. And the unit there is micrograms, okay? So that was a little bit of an intro today on how to do simple conversions. You can work on these other ones as well for more practice. There's more here, some word problems. We'll do some more of these next week. If you have questions, I'm going to stick around. Thanks for joining today. Keep your eye on your email. And thanks for joining us. If you got to go, we'll see you next week.